we're team A. Our problem is the number 1. This is the problem, x minus 1 over x squared minus 1. And the team members are Rafael Montes, Luis Carlos Calaves, Agustin Muñoz, and our professor is Carlos Domenzay. So the first thing that we have to do in 10 steps is restriction and domains. That is the part A. So we need to find our restriction, that is x squared minus 1, because in this part the only restriction is the one that is on the denominator. So in here we have to clear. So we clear the minus 1, it goes with a positive sign, so we have x squared is not equal to 1. So we need to quit this square. So we pass it to the other side with a square root. So we have x is equal to a square root of 1. That is the same as saying x is equal to minus plus 1. So we already have our restriction, that is plus minus 1. So we have to get our domain. The only thing that we have to do is put the values that we have. So we have minus 1 and 1. So the domain is x belongs to all the real values except minus 1 and 1, because these ones are our restrictions.
On step number 2, we need to get x and y intercepts. On the first one, that is x-intercepts, we need to get all the function equal to 0. So here we have our procedure, and our point number 1 is 2, 0. And then on y-intercepts, we need to get all of x of the function and 0. And here is our procedure, and then we have the second point, that is 0, 2.
If it's odd or even. So to determine if it's even, the only thing that we have to do is put a minus in the x's. So we put minus x because it's positive, and here minus x. So the equation goes to minus x minus 1, x squared minus 1. But this equation, this part, is not equal to this one. So we don't have even symmetry. And in the odd one, we have to change all the negatives with plus. So we have to multiply everything with minus 1. So this one goes to positive, positive, negative, and positive. So this one is not the same as this one also. So we do not have even or odd.
On step number 4, we need to get our vertical asymptotes using limit definition. On the limit definition, we need to substitute the value of the number that we choose on x. So here we have the procedure for x, limit of x when it's 1. We substitute it and we need to get undefined. So we get that our vertical asymptote is x equal to 1. And the same procedure on limit x equals to minus 1. Here we have again an undefined value, and we get the vertical asymptote means x equals to minus 1.
So the next thing is the letter E, that is horizontal asymptote. So in this part we have to use limit x to infinity. So we put limit x to infinity and our equation, that is this one. So x minus 2 over x squared minus 1. So we substitute the x's with the infinities. So we have infinity minus 2 and infinity squared minus 1. This is equal to infinity because a number to infinity is infinity. So we know that we have infinity over infinity. So in this part, the exponent is bigger, so we know that the y is equal to 0.
On step number 6, we need to get the first derivative of our function. So here we have our function. To get easier the procedure, we need to use quotient rule. Here is the procedure. It's the derivative of the first term times the second term minus the derivative of the second term times the first term over the second term at square. Here we eliminate parentheses. We didn't touch the one that is on the square downwards, and here is our result of the first derivative.
So in the letter G, we have to get the ID test, that is the same as the critical points. So since we got the quotient, well, the first derivative that we apply a quotient, we got this one. So 0 is the same as this one. So we have to equalize this this part, the result of the quotient to 0, and we have a negative here, so we have to change the sign of this one, and this one. So the first one is minus x squared, the second one is minus 4x, and the third one is plus 1. We only change the signs, and we equal to 0. So this part, it doesn't matter, so we only put the minus x squared minus 4x plus 1 is equal to 0. So when we have this part, we apply the general formula that is this one, that is minus b square root of b squared minus 4 times a times c, all of this over 2a. So we put the values in this part. So this one is a, this one is b, and this one is c. So the first one is b minus b, so minus, and the second one is minus 4, so we put minus 4. So then a square root of b, that is minus 4 to the square, minus 4 times a, that is minus 1, times c, minus 1. All of this over 2 times a, that is minus 1. So we resolve this, and we have 4 of square root of 16 over 2. And the result of this, we have two values, because we have one plus and one negative. So we have two values. One is x is equal to 0.268, and the other one is x 3.732.
On the step number 8, we need to get the second derivative of the function. So here we have that this is our first derivative. So to make things easier, we are going to use product rule. This means that we are going to multiply this by this, but all with this in negative. So we are going to do the first term derivative times the second term plus the second term derivative plus times the first term, and our result will be this.
The next part is the concavity test. So if we get the second derivative, that is this one, we only have to use the part that is inside. So we use x cubic minus 6x squared plus 3x minus 2. This everything is equal to 0. So in the calculator, we put this function. We apply the cubic function, and we have as a result this 5.522.